Hi everyone, my name is Cami Williams and I'm an Alexa evangelist, and welcome to the last multimodal session of Alexa Live. Woohoo, yay! I'm so glad that you guys made it this far because this session is the best session yet, and I'm totally biased in saying that, but today we're going to be live coding the Alexa presentation language. So you've probably heard a lot about it today, partially from me, but we're going to do a quick overview of it and then dive into the code. So if that sounds good, let's get started. So we have a lot of multimodal devices in the Alexa family, tens of millions, I might say. And this is only growing. And so for you as a skill developer, how can you tailor your skill experience to these devices? All of this is through the Alexa presentation language. We have found that our customers dive deeper into your skills if they have some sort of visual component to them. Now, that's not to say that skills that feature a visual component are better, but we find that it drives more engagement. Along with that, you can tailor your experience according to the device. So if you're on an Echo Spot versus a Fire TV, they're different devices. They can be found in different parts of the home, so you can change your skill experience accordingly through the Alexa presentation language. So we listened to our developers. We decided that we wanted to create this really awesome language that allows you to completely tailor your experience according to your skill and your personal brand. With the Alexa presentation language, you have full creative control over what visuals are displayed on screen for Alexa-enabled devices. You can decide to show video, images. We have some really cool components that you can incorporate that really marry your VUI and your GUI together, your voice user interface and your graphical user interface together. And you can optimize this to scale across those tens of millions of devices in our Alexa family. Finally, it simplifies navigation for customers. When customers are talking with your skill and interacting with your skill with their voice, they can also choose to turn and look at what appears on screen, maybe see some hints that you provide, but then just dive deeper into your skill overall. So how does APL actually fit into your technical life cycle? Well, a customer would invoke your skill using your skill invocation name. So they would say something like, Alexa, ask the Food Network for information about the flavor wheel. Their Alexa-enabled device would listen to this, and then it would take that utterance up to the cloud. The utterance is the action that the customer wants your skill to perform. And that's where we do the automatic speech recognition and natural language understanding. So essentially, Alexa is taking what the customer says, comparing it to the training data that you provided her in your interaction model, and pushing it to your service. Your service can be hosted on Lambda or behind an HTTPS endpoint, but essentially you are getting the intent. The intent is the action that you will perform in your skill. It's very intuitively named. But the intent is essentially a function. And in that function, you can make any web service or API calls that you like in order to formulate Alexa's response. As with any function in programming, you can also have variables with that function coming in as parameters, and those are slot values. So consider, again, a slot value, a variable into what the customer might say. So when you have all that information in mind, that's when you start to formulate your response, what Alexa says back to the customer. This is via output speech, which is done in SSML, speech synthesis markup language. So you can choose to incorporate any speech cons, inflections in Alexa's voice. You can use Amazon Polly to change her voice. The possibilities are endless, but the voice component is very important because you want to essentially paint the picture of what your skill is doing to the customer via voice. For example, if I was speaking only in monotone, you wouldn't be engaged, you wouldn't be listening to me, and that wouldn't be great. And so with Alexa, SSML is important because you can really utilize very personalized features in your output speech response. Now you might be noticing I'm talking a lot with my hands right now. It might be distracting to you, but consider this how you would consider your visual component to your skill. It shouldn't be the main thing that customers interact with. The main thing is voice. We have many, many customers that have headless devices, devices without a screen, and so we want to assure that their experience is up to par with experience that is a voice and graphical experience in a skill. That said, you can also render APL documents alongside your output speech. These are sent to the device in parallel, which means they're inflated in parallel, and they're written in APL. And APL is just JSON. And so all of that is then compiled and sent back up to the Alexa service in the cloud. And that's where we render the multimodal components, interpret that JSON into actual items that will appear on screen. And then those are sent to the device, inflated, the output speech is said, the visuals are shown on screen, and the customer is super excited because they have a response that they're satisfied with, and then can dive deeper into the skill. So with all that said, there are a couple things that you want to keep in mind when you're incorporating any visuals into your skill. As I mentioned, we advocate for a voice-first experience. Not necessarily voice only, but voice first. And so if you are incorporating visuals, they need to really complement your voice experience. You don't want them to be the main experience. So if a customer has a headless device or is even looking away from the device, you want to make sure that they are getting a response that makes sense according to their request. That said, you also want to optimize according to the device. With APL, you have the opportunity to get the device characteristics from the customer. And so using those characteristics, you can sort of tailor your skill experience according to what that device's purpose is. For example, if I'm on an Echo Spot, I have an Echo Spot in my bedroom and in my office. And I mostly use it as an alarm clock, and I look at it a lot when I'm programming or when I'm waking up or something like that. Versus if I have a Fire TV, that experience is more I'm sitting on the couch and I want to see what Alexa can present to me. It is more visual because that's what the purpose of a TV is. And so for me as a developer, with that knowledge in mind, I can tailor my experience to that device purpose, so that way the customer feels like it's a more personalized experience. Think of it in how you would have your conversations in certain contexts. If I'm in the office, my conversation is very professional, versus if I'm sitting on the couch, it's a little bit more personable, a little bit more laid back and relaxed. So with an Echo Spot, intuitively, you would just show the major points, get right to the point with your visuals, while if you're on a Fire TV, you might have a little bit more fun with the expression. You have more real estate to use for your visuals, and so you can show a little bit more fun things with there. So with APL, you have the opportunity to tailor your experience according to the device medium. Along with that, you want to make sure that your GUI and VUI make sense together and work as close to harmony as possible. So with that in mind, if Alexa is saying something, what you have on screen has to make sense with what she's saying. If I'm talking about puppies, I don't want to show graphs on screen. That wouldn't really make sense. So fortunately, we have some components built into APL. Components are just pieces of the JSON that you can utilize that will sync according to what Alexa is saying. And that sync happens with commands. Commands are things that can be sent alongside your APL document that can manipulate or render different components that appear on screen according to things that you specify. We'll get into commands a little bit later. It's a little bit more of an advanced topic. Finally, with all this said and done, visuals are something that we want to build a community around. One of the major benefits with APL is that you can host any of your layouts or custom components or templates on S3 or on GitHub and reuse them across skills. This not only optimizes your building as a developer, but also helps us as a community. For me, I'm a developer, I am nowhere close to a designer, and so I love being able to see what other people are doing with the Alexa presentation language, because that not only inspires me and helps me with my design, but it also allows me to see how other people are viewing voice and visuals together. So when all is said and done, we're hoping that you, the developer community, help us build this APL community and ultimately share what you've made, because we all want to help each other. So with that in mind, let's get into our live coding session. So I created a skill. Please forgive me for lack of creativity. It is called restaurant skill, but it is essentially a fake skill that I made up around this restaurant I like to call the Alexa Cafe. So I imagine someone using this skill would be familiar with my restaurant and want to know more about my restaurant on different times of day. So I have a couple intents that I've built into my restaurant skill. And remember, an intent is where you would perform any web service or API calls to fulfill the action that the customer requests of you. So the first is a launch request. So this would happen when a customer says, Alexa, open the restaurant skill. I would give some kind of welcome message saying, welcome to the restaurant skill, here's what you can do. Happy hour intent would be if a customer asks about the happy hour for that day. And so she would list off the items that were on happy hour and maybe the times for happy hour. Specials intent would be the specials for the evening. The item intent would be if you asked about a specific menu item or a specific happy hour or specials item. The about intent would give you just simple logistics behind the restaurant, like hours of operation, maybe directions to the restaurant. And then finally, we have the built-in required intents, which would be help, cancel, and stop. These built-in and required intents are required for every skill. And so I would need to make sure I have some sort of response if the customer ever asks for help or stop. So that's a summary of what the skill does on the technical side. Let's see how we would incorporate visuals into this skill. So we'll start with the launch request. This is the display that I had in mind. This is all written in APL. What Alexa actually says is, welcome to the Alexa Cafe. To get started, you can ask for things like restaurant hours, specials, or happy hour. What would you like to learn about? So with this display, again, it's not necessary, but it kind of just shows a little bit more information than the customer already gets. It shows what the dining table looks like, maybe the restaurant colors. Again, not integral to the experience, but just enhances the experience overall. So let's break down what we're looking at a little bit. All of my APL, again, is written in JSON, and it's made up of something called components. And there are different types of components, but components are essentially things that are rendered on screen. So the first component that we're seeing is called a container. And again, APL is very intuitively named, and so a container just simply contains things. So I have a parent container for all of the children that we see on screen, and this container is essentially specified by a height and a width. So you can see here in pink, it's highlighted. I just have type container, and then I have a width of 100 viewport width and a height of 100 viewport height, and then items where I would specify the children. You'll also notice that preceding this container, I have how I specify that this is of type APL. Now, all of your APL documents are sent in directives alongside your output speech, so it's important that I specify that type first, so that way the directive knows what type to compile my JSON to. In this case, it's obviously APL. So the first children contained in the container are two things called frames. Now, frames are very similar to containers, except you can think of them as containers with color. So I would use frames if I ever wanted to incorporate a shape, whether it's a rectangle, square, circle, whatever you may have, but I want it to have a color. So it looks very similar. The frame has type of frame, and then I specify the width and height, and in my case, these two frames are stacked on top of each other. So it's important to note that the container specifies the direction in which their children display. So in my case, the direction defaults to column view, so they stack on top of one another, but if I wanted them side by side, I would just adjust the direction to row view. Something also worth mentioning here is you'll notice that the height of each of the frames both equal to 100. It's important that when you're starting to compile your APL document, all of it equates to 100 of the viewport width and viewport height. This isn't required, but I found that this just helps me when I'm scaling across devices. It also makes it more efficient for me when I'm writing my APL documentation. I don't have to write something specific for every type of device, whether I'm on a Fire TV or on an Echo Show. I have the ability to scale according to the viewport height and viewport width as long as they equate to 100% of the device properties. And then obviously the frames have a background color property in which I can specify what color I want the frame to appear as. Now you'll notice here that I'm actually using variables within my APL document. These variables are called resources, and they're denoted by the @ symbol. And so I called my variables my blue and my orange. So what's nice about APL is not only can you scale them across devices, but you can also create your own personal brand, your own library of specifics within your various documents. So while my blue and my orange are specific to this skill, if I like those colors, I can reuse them in other skills because I'm essentially creating this pack of things, this pack of resources that I can then host and reuse again and again. So this not only applies to resources, but it also applies for styles and layouts. So styles, if you're familiar with front-end programming, it's pretty similar to CSS. It's essentially something that you can apply to various components, and they can be inherited and extended. They can also be set against a condition. So what this means is you can specify a font size, font weight, color, background color, whatever you may have, and define it as a style, and then have a style attribute associated to the component, and that component will inherit that style. Along with that, the styles can be extended. So if you want styles to build off one another, they can do that as well. And then styles can also be built against conditions. So if you only want a style to be applied according to a certain condition, you can do that as well. Next is resources. I've already mentioned this, but these are global variables within your APL document. So resources have specific types that they can be. You saw in my document, I was specifying color names, so you can have a resource of type color. This can be hex, RGB, RGBA, essentially any web-safe colors as well. It can also be dimensions, and the dimensions we support are vast. You can do pixels. You'll notice that I did VH and VW. Resources can also be strings. So if you want to specify a specific title, or you want to utilize a string for a URL that you'll use later, you can save that as a resource so you don't have to keep copying the same string over and over. And then finally, Booleans. So these can be your conditions or Boolean variables that you use however you'd want within your skill. Now, resources are cool because they are the first thing that is inflated on the device. So when the whole APL document is actually sent to the device, it is inflated in a specific order. And resources are the first thing that's inflated. And so you can utilize resources in any part of your APL document. So I can use those global variables in styles, in layouts, in my actual main template, anywhere in my APL document. And it also, again, helps to host them because I can reuse them across my documents. And then finally, one of the things I love, I think it's one of the coolest parts of APL, are layouts. So layouts are essentially composite components. They're components that you create yourself. They're fully customized. So if I wanted to create a component called Cami that consists of an image and text, I can do that, and I can reuse my Cami component throughout my APL document and if I host it across my skills. And so this piece is the part where we are building our community off of. For example, I created a timer component, and so I host that on my S3, and I'm able to reuse that across my skills. And I have it public, so I allow the community to host that as well. So layouts are probably one of my favorite pieces, and we'll see that in action in a little bit. But going back to resources, let's see how they're defined. So at the top of your APL document, right under the import statement, you have resources. This is just an array of JSON objects, and each JSON object represents a grouping of resources. So to define a grouping, I set a description. It can be as simple or as complex as you want, but I just set it as colors. And then I set my type. So again, your type can be colors, strings, dimensions, and Booleans. So I would define my type as colors, and then I would name my color and associate a value to it. So in this case, I name my colors my blue and my orange, and they have a hex code associated to it. You can also see under that, I have a resource for images. So images, that would just be an image URL. I would specify that as a string. You saw on that launch screen that I had a table image, so I would just set that variable, name it table, and then set that to the URL in which the image is hosted at. So let's look at what the image component looks like. That's the next component that appears underneath those frame components. And again, this is just being pulled from my resource, but the image is hosted on S3. So this is what an image component looks like. You'll notice that I put it in another container. If you're familiar with front-end styling, I have the position of that container set to absolute. I do this because you saw we had the frame stack one on top of the other. By setting the position to absolute, that's saying anything in this next container show on top of those frames. And so in order for that image to appear on top of the frames, I have to set the position as absolute to its parent. So anyway, going into the image component, you can see I have the source pointing to the table resource denoted by the @ symbol. Then I have a height and width. I set the position according to where its parent is located, so I can also set the position absolute to that actual image. And then I have a scale attribute. So scaling is important. Again, if you're familiar with front-end programming, this is intuitive as well. I set my scale to best fill. You can also do best fit. All of this, though, is documented on our tech docs for APL. Now, with images, I didn't do it here, but it's important that when you're considering building for multiple devices, you want to have different image sizes that will render appropriately according to the device characteristics. So an image that I have rendering on a Fire TV should be larger than the image that I have rendering on the Echo Spot. So if I were to push this skill to production, I would actually have multiple instances of that table image and then have a condition on the resource saying if the device characteristics are small and round versus extra large and TV, use different images accordingly. Even though they're the same, it's just a way for me to optimize my APL document so that way I'm assured that it inflates and renders quickly so the customer experiences no delays. Now, not to scare you off, the delays that they would experience in rendering are minimal, but it just is assuring to you and me that the customer is experiencing the best skill as possible. So finally, the last components that I have on this display are text components. And text components are probably the simplest. They're also very intuitive. You would specify your text component, any font size, font color, but then the actual text that appears on screen. So I have a box around this as a whole, but I actually have 3 text components here. You'll notice too that I can have inline markup. So I have the and cafe italicized. I can do that again in line with the text. But then the styling is all very recognizable as well. I have them all separate though, so I can offset them in a way that I like. And you can see that here the positioning is a little bit different for each of those. So let's switch over to our authoring tool really quick. And you can see my display in action here. So this is the Alexa Presentation Language Authoring Tool. You can find this on the Alexa Developer Console. If you're in your skill, go to the Build tab, and on the left-hand menu, scroll down and click Display, and you can see this authoring tool. But this is my APL code altogether. I'll just scroll down really quickly. You can see I have my main template. I have the parameter payload, which I'll explain in a little bit. But the items are exactly as I displayed before. I have my parent container, along with my 2 frames, my blue, my orange, and then another container that houses my image, and then my 3 text components here. So this updates directly. So if I just said the Alexa Cafe is great, then you can see it appears right there. Along with that, because I have the resources, any instance of the resource will be updated if I update that resource. So if I wanted to change my orange to, let's say, red, then that would appear on screen as well. So one of the coolest things about this authoring tool is that I can actually toggle between my different devices. You can see that up here. So we have a couple examples of the devices. Here we have an extra large TV, and it gives you the dimensions for those. Then I have something called a large hub, which is synonymous to the Echo Show 2nd Gen. I have a medium hub, which is synonymous to the Echo Show 1st generation. And then finally, I have a small round hub, which is synonymous to the Echo Spot. So by clicking between each of these, I can see what my display looks like across devices. Another cool thing is I can actually add a custom device. So if I have an AVS device that I'm building for, and I want to ensure that my APL display looks great on that device, I can actually create a device accordingly. Now, that's not to say that you're not covered by these devices. If you only build according to the devices we have on the authoring tool, rest assured that you'll be good, but it's just for basically your own sanity or your own experimentation. If you want to create your own device, you can. Cool. So this is the layout that I would use for my launch request. To actually put this in my skill, I would use something called an APL directive. So the first thing that I would want to do before I use that directive is check and see if APL is supported. So in my skill manifest, I have to support APL, say that my skill is using APL. So that way, when the customer interacts with the skill, we know that it is a possibility. But then I also have to check and see if it's a headless device versus if it is a device with a display. If it's a headless device, we don't want to send the APL document because we don't want to confuse the device, but it also just helps with our response size. So the first thing that I would want to do is I would want to use this supports APL helper function. This is something that lives on our Alexa cookbook in our GitHub. So if you want to see this code live in action on some of our skill examples, you can check it out there. But I would incorporate this in my index.js if you're using Node.js, essentially in your main file in your Alexa skill. And then within my actual launch request, I would call that helper function against the handler input to assure that APL is supported. And if it is, then I would send my APL directive. Again, a directive is something that just tells the compiler, hey, compile this next piece as this type. So I would specify my type as the alexa.presentation.apl.render document, meaning that you need to render this next document on screen. And then I would specify that document as my JSON, my APL. Now for me, just for my own sanity, I like to save my APL documents and name them according to the intents that they're used in. And so in this case, I would save that chunk of APL as launchRequest.json. And this would just live on the same stack as my Alexa service would. And then you would send the response. And it's that simple. So with that in mind, we created this launch request screen. But it doesn't actually just have to be for the launch request. I like this screen, and I can use it across multiple intents. It doesn't just have to live for one intent. What this means is if you want to show the same screen no matter what the customer says, you can send that directive with every customer response. But in my case, I would probably use this display for my launch request, for my about, for my help, and for my cancel and stop intents. Now for about, you might be saying, oh, well, what if I want to show the hours of operation, or what if I want to show the directions? You totally can. But again, my skill is voice first, as should yours be. And so I'm okay with not necessarily displaying the information that the about intent says, but more just complementing that about intent experience. So with that in mind, the next display I would want to build for is the happy hour intent. So this would be if the customer says, tell me more about happy hour, or tell me more about the happy hour items for tonight. So now for this one, I have two different experiences. It might not look different at first, but trust me, it is. And so in this case, I would want to display a list, and I would want to display a list according to what the happy hour items are. So if you can imagine, if I have a web service that would be able to grab those items for the evening, I would call that web service in my actual skill code, and then I would want to send those to the APL document and have them be inflated on screen. I would also want my APL document to be dynamic according to those list items. Some nights for happy hour, I might only have one item. Other nights, I might have 10 items. I don't know. So I would want my APL document to adapt accordingly. And then finally, you'll notice the difference between devices. You can see on the landscape device, I have the list item, and then it has a tell me more button on it. Versus on the small round hub on the Echo Spot, I have just the list item. So in this case, when the customer taps on the Tell Me More button, that would then take them to the item intent. That would show them more about that specific item. But then on the Echo Spot, because I have a little less room, I wanted to make the entire list item a button. So in order to do that, I'm utilizing the Visual Characteristics Framework. This is essentially the viewport. It gives you information about the device that you're using, and this information is the height and width, the shape, the orientation of the device. We create a library behind that though, so you can easily trigger different device families according to their viewport, or you can just make very simple conditions behind them. So that's what I'm doing in my case. I'm saying if the hub is round, show this, otherwise show this. This Visual Characteristics Framework is actually also accessible not only in your APL document, but also in your skill code. So in theory, you could actually change what Alexa says according to the device medium. Now, I'm not advocating for that, but it is possible. So in some cases, let's say you're on Fire TV, again, you want to show a lot of visuals, make it really engaging in that sense. You might also want to say a couple more things. Versus on the Echo Spot, I'm showing a little bit less, so maybe I'll say something different. But again, it's up to you. You just want to make sure that the overall voice experience is equal across different devices. The customer is still getting the same thing that they asked for. So in order to access this and utilize this, I would import something called Alexa-viewport-profiles. Again, this is the library of groupings that we made against the viewport, so that way you can trigger multiple device families. And then I would use something called a when clause. Now, a when clause is similar to an if statement. It just houses a condition. And so in my case, I'm using data binding, and I'm saying against the viewport profile, if it is equal to a hub that is round and small, meaning an Echo Spot, inflate this component. Otherwise, don't inflate any of the other components if they have a condition that is not equal to this. So if I have a component that has a condition and it is not met, then that component would not be inflated on my device. Now, this is to say you can also mix and match. You can have some components with conditions and without. Just note, if they don't have a condition, it will always inflate. So let's see this in action. I'm going to switch over to my Alexa Cafe display for happy hour. So you can see that if I toggle between my devices, it updates my display. So again, this Tell Me More button is available on all my landscape devices, but on my round device, this list item is completely tappable. Now, you'll notice I'm importing something called restaurant components. Restaurant components is something that I wrote and I hosted in an S3 bucket, and I made public. And it's hosted and it contains items so that way I can make my APL document a little bit smaller. So let's look at what this looks like on the APL side, and then I'll show you the hosted code. So you can see I have my frame here. I have my blue variable. You'll notice I don't have any resources specified in this APL document. That's because I hosted my resources in this restaurant components file. Scrolling down a little bit further, I have my logo component. My logo component is just this Alexa Cafe logo. So if I deleted this, then that logo would go away. Oh no, but putting it back, you can see it just lives as any other component would, just as a text or image component, but I just specified it as my logo component. Then I have a frame. This is the frame that kind of houses my list. Within that frame, I have a scroll view, so I can scroll over the list items. And then I have a container that has data coming in. This data then is mapped to a list item, so it's saying for each item in this data, create a list item component. And that list item has the properties of title and subtitle. So list item is another component that I've hosted in my restaurant components file on S3. Let's take a look at what all of these look like. So this is the hosted URL. You can see it looks exactly like my other APL document, just living here. I have my resources. I don't have any styles associated to this, but then I also have my layouts. So within my layouts, I have my logo, which just contains text. I have my list item, which shows different list items. And you can see within this list item, we have a touch wrapper. This touch wrapper component also says on press, send the title to my skill, send this event title. So that means that when someone clicks on the list item, it'll send the title of the list item. So in my case, it would send wine, beers, appetizers, desserts back to my skill. So the next piece that's worth mentioning here is the payload. I mentioned it earlier, this lives as parameters for the main template. The payload is information taken from the data source. Now, your data source is something that you would send in your directive, and it's information from your skill that you want to push to your APL documents. So as I said before, if in this restaurant, imagine I made some kind of web service call that would get me my most recent happy hour items, I would take that information that I was able to call and get a response from in my skill and put it in my data source and then send it alongside my APL document. And so in order to mock this, if you click on the Data JSON tab in the authoring tool, you can see I have restaurant data, and then I specify the properties of my restaurant data. I incorporate a title just so I know what type of data I'm sending, and then I would send these restaurant items. Imagine this is coming from some sort of web service call. So if I change wine to, let's say, cheeses, you can see that list item updates accordingly. So what this looks like in action is when I am sending my directive alongside my response, I would, again, specify that type as APL render document, send the document alongside it, and then in data sources, I would send my restaurant data. So in this case, again, I would set the title, and if you can imagine, I have a happy hour item variable. I would send that alongside that item's attribute. So once that variable is populated, I can just append that to the data source, and then that will be inflated on my APL template. So what's nice about this is I can actually reuse this template for my specials intent as well. To show you that, all I would have to do is update that data JSON. So this is the exact same template. The only difference is the data JSON I send. So when I make that web service call to get the specials, the only thing I'm updating is my data source. But it is able to show the same information in the same APL document. So again, all about reducing work for myself. So now that we have happy hour and specials, let's talk about our last display we would want to create for the item intent. So with the item intent, in order to get there, I would first have to either interpret the voice utterance that the customer says, or that touch item. So if they said, Alexa, tell me about the filet mignon, I would interpret that as I would any. I would be able to capture that item as a slot value and interpret that as an item intent. Or I would capture it as a user event if the customer tapped on one of those list items on the display. So you'll remember seeing in the touch wrapper in my hosted code, I use a send event and I send the title of that item, and that comes to me in my Alexa service as an APL user event. So I would want to check that it's a user event, but I would also want to check that the arguments that I sent with that user event were populated. So I would want to check that the title is actually sent to me. Then in my code, I would check and see if the request type was a user event. If it was, then I would specify the selected food as whatever the customer tapped on, or I would check the slot value and see what the customer said, what item they asked about. So then I would display what I would want to show, more information about that menu item. In this case, if they asked for more information about pasta burrata, I would show a video of the pasta. And then on the landscape, I would show the title and then a description of that menu item. On the round hub, I would just show the description of that item. Alexa would say that item, and then she would play the video once she is done talking about that item. So what's nice about APL is we have given you the capability to use what the video directive offered in your actual APL document. So you're able to play and render different videos in your APL document very seamlessly. And in order to do that, you would just use a video component. So with this video component, it's very similar to what an image component would show. You'd specify the height and width. The source I'm getting again from that data source. You'll notice too, I have a couple commands associated to these, on pause and on play. And then I would have an ID associated to it. It's important with videos to also always specify an ID, so that way you can send various commands to your video component. When you have anything like buttons or video in your APL code, you want to make sure that also in your skill code, you can accommodate the commands that a customer might do with their finger with their voice. So if a customer says play or pause the video, I would want to specify an ID for my video, so that way I can send from my skill directly to that specific ID to play or pause. Along with the video, like I said, we have this on pause, on play. And you'll notice that it is triggering to an Alexa play pause toggle button. Before, you'll see a little bit, it's a little hard to see, but on the video you can see we have a play pause and then a tracking button to be able to fast forward or rewind. All of this is written with an Alexa transport control. So you'll notice that the component that this transport control is associated to it is matched by the ID, and then I can just specify whether it autoplays after Alexa is done speaking, and then style it in a way that is pleasing to me. So to see this in action, what's nice about this is all I have to do is host Alexa-layouts. I have my restaurant components here. I have my data source that's being read, so all I would do is specify what item I'm using. So I'm using the pasta burrata item. And then I have my Alexa transport controls. I also have a condition where if the viewport isn't round, then show the title. And you can see how the display renders according to the different devices. So again, this is an authoring tool. This is not an emulator, but within the authoring tool, I can actually choose to play the video and see what it looks like on screen. That said, again, because this is just an authoring tool, you want to make sure that you're always saving your code and pushing it to your Lambda service or behind your HTTPS endpoint. This is not saved to your skill. This is just a way for you to design your different screens. So with that in mind, I have built out all of my screens for my restaurant skill. For the launch, about, help, cancel, stop, I had a simple display that just showed the title of my restaurant and an example image showing the different table that might be at my restaurant. For the happy hour and specials intent, I use list items and logos that I hosted on S3, and I use data binding from my data source in order to populate the list. And then for my item intent, I used data binding again from my data source in order to get the specific list item that the customer specified, whether they said so or touched an item from the previous screen. And then I used a video to show the customer a little bit more information about the dish that they requested. So again, with all of this, you can reuse and share your APL across the community. You'll notice that I hosted my components on S3, so that way I can utilize them in different skills and future skills that I make. We're hoping that this is something that you do and that you start to learn from, and then it can just be easier for you to develop more and see how GUI can easily be married to your VUI. So now, when all is said and done, I really encourage you to experiment with APL. It's one of my favorite things about skill building. To get more information, you can go to alexa.design/multimodal. This will be your one-stop shop for building things with APL. If you want to see some examples that we've created with APL, you can go to github.com/Alexa or github.com/Alexa-labs. What lives on -labs is a little bit more experimental, so you'll see a lot of our new features there, but definitely check out both for some awesome code samples. And with all that, I'm really happy that you guys stuck around for so long. My name is Cami. I hope you guys have a good rest of your day, and I hope you enjoy our closing keynote. Bye, everyone.